My name is Clay Brown, and this tutorial video is going to be on quadratic equations. More specifically, it's going to be on how to solve quadratic equations using a method known as factoring, also known as solving by inspection. Now, just to be sure on this, so we all are on the same page, what we mean by solving a quadratic equation is that we want to determine what values to set x at so that this equation does in fact equal what it says it does, which is 0. Okay? We also want to make sure that we understand that these coefficients in the first term, the second term, and the third term, a, b, and c respectively, that they are constants, which means simply that they are integers 1, 2, 3, 4, 5, 6, and so forth and so on. And one condition on this, in order for us to solve this by factoring, is this here. We have to make sure that a does not equal 0. A cannot equal 0. Now, why is that? Why is it that a cannot equal 0? Because we know that anything times 0 equals 0. And if we set this at 0, that means this term becomes 0 by multiplying it by such, and therefore it no longer qualifies as a quadratic equation. Now, the second issue we want to deal with is, how do we start? We start by taking this equation and changing it into this equation, x plus r times x plus s. In order to do that, and by the way, r and s are simply constants, just as the first, second, and third coefficients are, we have to make sure to follow this condition, and that is when we set the values, determine the values for r and s, r times s must equal, let me get this out of our way a little bit. Okay, there we go. R and times s, the product of such, must equal c, which is this coefficient here. And those same values that we set for that, for r and s, when added together, the sum of them must equal this coefficient here. Once we establish that those conditions are true, then we can in fact solve by factoring. If they are not true, then we have to find a different method. So, let's move on to the next. We've got this. We've got this. We've got this. Now, the third thing we need to make sure we're aware of is to find the values for x to solve this equation. We must reduce x plus r and x plus x to 0 by choosing the right values for x. Okay? And we know that anything times 0 is 0. We learned that up here, right? Anything times 0 is 0. If we can set either one of these equations to 0, this one or this one, then the entire equation will become 0. So, what value of x would make x plus r equal 0? And that is x would equal minus r. Because minus r plus r is the same as r minus r. We can move these around, right? As long as we keep the signs, the negative or plus signs, consistent, it's going to equal 0. Anything minus itself is 0. Likewise, for this one here, x would equal minus s, because s minus s equals 0. And when we do that, we will have a solution. Now, let's go on to the next slide, and let's actually do some work. X squared plus 6x plus 5 equals 0. Okay? What is the value for r and s? We know that r times s must equal c, or, in this case, 5. So 5 has only two numbers that when multiplied together can equal 5, and that is 5 times 1. Now, does 5 times 1 equals 5? Okay. Those are our only two options. So let's put 5 and 1 here. Now let's see if it meets this, those numbers meet the second condition, and that is r plus s must equal b, which is 6. Well, does 5 plus 1 equal 6? Yes, it does. So we know that we can solve this equation. By fact, there is an intermediate step, and that is we need to make sure, verify that this equation right here, or this, and this is going to be equal to 0, right? Is the same as this when we multiply these two together. In other words, we're going to end up with this. We are going to use the FOIL technique. Okay? FOIL. Hopefully you remember that, but if not, you're going to relearn it. F stands for first. We take the first term and multiply it by this first term. X times x is the same as x squared. The second is the outside. We're going to take the first term and multiply it by the outside term of this one. And we know that x plus 1 is plus x. Next, I in FOIL stands for inside. We're going to multiply the inside terms. 5 times x is plus 5x. And then last, L for last, we're going to take the two last terms. 5 times 1 equals plus 5. Let's put this in simpler form by taking like terms. There is only one term that has an x squared in it, so that comes down, x squared. There are two terms that have an x in it, so we add those two like terms, which x plus 5x is 6x. And then we have only one term that has simply a constant in it, 5, so we drop it down. So, are we correct? Yes, we are. X squared plus 6x plus 5. These, although they don't look the same, give us the same value. Okay? Therefore, they are the same. As we learned, anything times 0 equals 0. So if I set this to 0 by choosing the appropriate x value, then this times this will equal 0. And then likewise, if I set this by choosing the appropriate x value to make this equal 0, then this times 0 will equal 0, and we will have solved the equation. So, if x equals -5, we're setting this to 0 now, then we know that -5 plus 5 equals, we can flip this around, make it a little more obvious. 5 minus 5, right, we just move this to the back, which we can do if we keep our positive and negative signs consistent, equals 0. So we've got the first solution, x minus 5. Now, if we want, now we have one more solution. Why? Because we have one more. Let me put this value back here. There we go. Because we have a solution for setting it based on this going to 0, or we have a second solution based on setting this to 0. So we have two solutions. Okay? So we can also set finding this one, x equals -1, which means 1 minus 1 equals 0. Yes, that's true. So we have two solutions, and we're going to put it in a conventional form that many teachers will have you use. When there's more than one solution, we'll put them together, separated by a comma. And that quadratic equation has been solved.